Okay, let's talk about the domain and the range of a function. So, definition, the domain is the set of all x values of a function. We call that the input. And the range is the set of all the y values of a function, and we call that the output. Sometimes there's a small function like this one. Okay, let's list the domain and the range as a set. Okay, so what does that mean? I'm trying to get rid of that little dot here. There. Okay, that means that we'll put D or for domain. And a set has these little, they're called braces, the little curlicues. And we can just, as a set, list the domain, which are the x values, as 0, 1, 2, 3, 4. And that's the set. And let's put R for range, which would be all the y values. And we'll list 0, 1, 4, 9, 16. And that's what we call a set. Okay. Let's move on a little bit. Sometimes there is a function with infinite parts. Oh, goodness. Okay, we'll go like this. All right, sometimes there's a function with infinite parts to it, like this semicircle. What is the domain and range? Now, what do I mean by infinite parts? Well, sure, x can be equal to 1, and y can be equal to, well, a little bit less than 3. And x can be equal to 2, and y can be, a little bit more than 2. And x can be equal to 3, and y can be equal to 0. And x can be equal to, you can see these points, right? But there's also x is equal to 0.5, and there's a value on the range. And if the domain is 1.1, then we have a range. We have a piece to that function. There are infinite little pieces in between 1 and 2. There are infinite numbers, 1.11, 1.111, 1.131, 1.999999. Okay, so that's what this means. So we have to talk about the domain of this function are all of these numbers. Okay, so basically they're the numbers on a number line from -3 to +3, including all of those in between. Zeros in there too, okay? That's what we mean by infinite. And the range, well, those are all, it really only goes from 0 all the way to 3, okay? And every number and infinite numbers. So I'm going to just show the picture. Even though it goes up and down, it's really from 0 to 3, including 0, including 3. Okay, now we can use this as a graph, which is what I just did. I'm going to do it again. So my domain, if you think about this as an inequality, is all the values from -3 to 3, including, so we put equal to, so less than or equal to 3, greater than or equal to -3. Okay, and this is the graph right here. All right, now I'm going to remind you, or let's talk about interval notation and set notation. So if you look at that graph, interval notation, all we have to do is take this endpoint, and we write it like that. And then we take that number underneath it, comma, and that number underneath that. This means all of the numbers from -3 to 3, including the endpoints. Okay? And finally, set notation. Make that a little thinner. Okay, set notation now really just takes the inequality, but it puts it inside the little braces, like we talked about a set, but it also has for all x such that. So this is an x. Oh shoot, I should do that differently. That's actually not a slash. That's going to be a backslash. For all x straight up and down such that, and then they just write x is greater than or equal to -3 less than or equal to 3. Close the brace. That's set notation. Hopefully you've had a bit of this in your background. This is introduced in Math 60, used in Math 65, but if not, it's in our textbook and you can do a review and we'll be practicing as well. Okay, now let's talk about the range, which is from 0 to 3. Okay, so the range, the inequality looks like this. I think I'm just going to try to move, nope, this way. There we go. Okay, so let's go back down. There we go. Okay, so the range is from 0 to 3, and the graph looks like this right there. And the interval notation, we take from the graph, we take these two endpoints and put them right here. And we put this left number endpoint, comma, and the right one. Set notation, we have a brace, all x such that, and then we're basically writing that inequality. So 0, oops, sorry, we're going to put y on this just because we can do that in set notation. So for all y such that 0 is less than y is less than or equal to 3. Okay. All right. So let's do some verbal, number line, and interval notation examples. Okay. All right, so let's look at all the real numbers that are greater than 5. That's the verbal. Let's look at the number line. Greater than 5 means here's my 5. I don't want 5, I want greater than 5, so that's when I use the parenthesis, and we're talking about these guys. And then our interval notation will be take the parentheses, take the 5, comma. Now, if it goes forever, that's to infinity. And that's the highest number you can go to, which isn't a number, it's a place. And infinity is always an open parenthesis. Okay, and didn't say set notation, so we'll hold off on that. Okay, let's do the next one. All real numbers between 3 and 7. Okay, graph. Here's 3, here's 7. We do not want those, we want between them. So we're going to open, and we're talking about these guys. Okay, so now interval notation takes this parenthesis and this parenthesis, boing, boing, the number underneath it, and the number underneath that, and that's it. And that means all the numbers, real numbers, meaning fractions, decimals, everything, between 3 and 7. And then let's do all real numbers except 7. Oh boy, okay, so on the number line, here's 7. Wow, we want all the numbers this way and all the numbers this way, but we don't want 7. So how we do that is, this is the direction of negative infinity. This is the direction of infinity, okay? So we will take this negative infinity, which is a parenthesis, comma, to 7, don't want 7, and then we use the union, which means or, so that means we want all of these numbers or all these numbers can all fit. And then we'll take the 7 again, but we don't include it, and we go to positive infinity. And that's the interval notation. Okay, now let's talk about set notation. For small sets, oops, shoot, let's go with yellow, there we go. All right, so let's see why we have set notation. The numbers 3 and 5, okay? Set notation just means I have a brace and I list the members of the set. That's not to be confused with back up here where we had set builder notation. This is what this one is. I did set builder notation here, and you'll see the difference here, okay? So set notation is just listing members of the set. So the days of the week, we got it. We've got it. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. That's set notation for a small amount, a finite number of pieces. Now, set builder notation can be used for both small and large. And the difference there is that we use the this part right here in the beginning, for all x such that, and that goes with the set builder notation. You're just going to have to like practice the difference between them. Okay, we rarely use sets like this unless we're talking about really small amounts of members. Okay, so let's practice this. We're going to do both interval notation and set builder notation. Okay, so we want all the numbers greater than 5. I always look at the graph first, it helps me. So I want to go this way, all these guys. So interval notation takes this and the 5 and the comma and goes to infinity. Set builder notation is the one with the curlies, all x straight up and down such that, and all we do is we take this inequality and we write it, x is greater than 5. Okay, let's talk about 3. So here we're on this one. That's x is greater. Okay, let's do greater than or equal to 2 and less than 5. So we just take, oops, because it's equal to, I want to graph it first. It's just so much easier for me to see it. Okay, so we get the 2, we get the 5. Now, greater than or equal to means I want the bracket, and less than means I want the parenthesis, because that just helps me. I put the bracket and the parenthesis. I just copy what's on my graph, and that's interval notation. And then this set builder, all x such that, and then you just repeat the inequality that's right there. Okay, and one more. Okay, we're running out of a little room here. Let's do a couple. Okay. All right. Okay, so one more. Oh, didn't take that with me. Okay. All right. So let's go from greater than 3, less than or equal to 6. I always look at it on the graph first. There's my 3, there's my 6, greater than and less than or equal to. And that tells me to put that and that and that and that. And then this just takes all x such that, and we just rewrite that inequality. Okay. Okay, let's take a break here and come back for part B of this video.